Welcome back to the Deep Dive. Today, we're really getting into a challenge that, well, faces pretty much every serious sysadmin candidate out there. It's that mountain of commands you need to memorize. And not just kind of know them, but have them ready for flawless instant recall.
Yeah, absolutely. Especially for something like the RHCSA.
Exactly. We're focusing on the Red Hat Certified System Administrator exam prep today. Because in that exam, time is just brutal. And getting the syntax perfect, non-negotiable.
That's it. Passing or failing, it often boils down to pure speed in these performance exams. If you hesitate for, say, 3 seconds trying to remember the right flag for user add, those seconds just pile up fast. So the sources we looked at, they outline this really solid 3-part strategy. It's designed to basically eliminate that hesitation.
Okay, so we're unpacking this strategy. It sounds like it has 2 main pillars, 2 things you absolutely have to do.
That's right. First, you need consistent hands-on lab practice. That builds the muscle memory. Second, flashcards, but specifically using spaced repetition for, the mental retrieval part.
Right, the actual remembering. And then there's a third piece. You mentioned making it modern.
Yeah, and this is where it gets really efficient. The third element is using generative AI, something like Google Gemini, to create the flashcard content itself, but making it super targeted, laser-focused for that quick recall.
Interesting. Like a 21st century study hack for sysadmins.
Exactly.
All right, let's unpack this. We should probably start with the real opponent here. It's not really the OS, is it? It's more about how our brains work. Or maybe how they don't work when we try to just cram things in.
You're talking about the forgetting curve.
Yep, that's the one.
It's a huge concept from cognitive psychology, and it's critical for technical study. Basically, it shows how information we learn just naturally fades away if we don't actively reinforce it.
So I could spend a whole day mastering, LVM commands.
Right, and feel great about it. But if you don't revisit them systematically, you could lose like 50, even 80% of that knowledge within just a few days.
Wow. Okay, and that explains why just rereading notes or cramming feels so inefficient.
Totally inefficient. You're not targeting the decay. You end up reviewing stuff you already know pretty well, wasting time. And the harder stuff, you basically have to relearn it because you waited too long. It's a nightmare, honestly.
Yeah, it really is.
So the sources we looked at, they pretty much dismissed those traditional methods straight away. They just aren't precise enough for the sheer volume and detail needed for RHCSA.
So what's the targeted solution they propose?
Well, it's a tool that's become almost standard in fields that require a lot of memorization. It's called Anki.
Anki, okay. I've heard of it. The name means memorization in Japanese, right?
Fittingly, yes. And what's brilliant about Anki is that it's specifically designed to solve this forgetting curve problem. It outsources the scheduling nightmare.
How does it do that?
It's free and open source software, FOSS, and its core is a spaced repetition algorithm. It automates scheduling your reviews.
Okay.
It shows you the information at the perfect moment, that critical point, just before your brain is about to actually forget it.
So instead of me manually deciding, I should probably review LVM again, the software handles that timing.
Precisely. It stops you wasting time on concepts you've already mastered. If you reviewed something yesterday and marked it easy, Anki might hold that card back for days, weeks, even months.
But the things I struggle with,
those come back much sooner, maybe the next day. When you review a card, you tell Anki how well you recalled it, easy, good, or hard. That feedback directly tunes the schedule for that specific card.
So it adapts to my personal learning speed for each individual fact.
Exactly. It's based on scientific principles, actually rooted in older algorithms like SuperMemo's SM2. It calculates the optimal interval to maximize long-term retention efficiently.
That makes a ton of sense for something like command syntax, where perfect recall is key. But here's a potential issue. If Anki is just drilling pure memorization, isolated facts, don't you risk losing the context? Like, you might remember the PV create command, but not really why or when you'd use it in a real server situation.
That is the absolute critical point, and that's precisely why the sources insisted. Anki and hands-on labs must be paired. You can't treat them as separate things.
Okay.
Doing them in isolation is a trap, because the RHCSA isn't a multiple-choice test, it's performance-based. They test if you know it and if you can actually do it under pressure.
So you need both, the mental recall from Anki and the muscle memory and understanding from the lab.
Exactly, working together.
So how does this ideal workflow look? How do you actually combine them effectively?
Okay, so for RHCSA prep, the strong recommendation was a consistent, ideally daily lab routine. The source is mentioned using a VM running Rocky Linux specifically.
Rocky. Why not CentOS or Fedora or even RHEL itself if you can get a developer license?
Good question. Rocky Linux aims for that 1.1 binary compatibility with Red Hat Enterprise Linux. So the environment feels identical to the exam, minimizes surprises.
Makes sense. Keep the variables low.
Right. And running it on a cloud platform like Linode was suggested because it's cost-effective, flexible. You can spin up, destroy, and rebuild your lab environment instantly.
Which you definitely need when you're practicing things like partitioning or messing with network configs. You want to break things and fix them repeatedly.
You need a sandbox you can trash and reset in seconds.
Okay, so you've got your lab set up. What's the workflow that links the lab to the Anki recall?
It's a reinforcing loop. You start with the hands-on. Let's stick with the LVM example. Logical volume management. It's core RHCSA stuff.
Okay.
So you go through the steps in your lab, initializing disks as physical volumes, creating volume groups, carving out logical volumes. You're typing the commands, seeing the structure change.
Building that practical understanding, the why, and the muscle memory in your fingers.
Precisely. Then, the crucial part. Immediately after you finish that lab session, you switch to your Anki deck, but only the deck related specifically to LVM commands.
Ah, so you're not reviewing everything, just reinforcing what you literally just practiced.
Yes. The Anki deck isn't asking, explain LVM concepts. You just did that in the lab. It's asking for pure syntax recall.
Give me an example. What would an LVM Anki card look like right after the lab?
Okay, so the prompt might be, command to initialize a partition as an LVM physical volume, and you need to instantly retrieve.
VG create.
Exactly. Or command to group physical volumes into a volume group.
That would be VG create.
Right. And command to create a logical volume from a volume group.
LV create. Got it.
See, the lab provides the context, the what and why. Anki isolates and drills the pure how to type it right now part. It's separating understanding from instant retrieval.
Which is exactly what you need in that timed exam setting.
Well,
you mentioned you could flip the order too.
Yeah, absolutely. Using Anki before the lab session can be a great warm-up. You prime your brain with the syntax you're about to use.
So you're not wasting lab time looking up basic flags in the man pages.
Right. You hit the lab already knowing the tools. It trains you not just to recognize commands, but to produce them accurately, almost without thinking.
Okay, this whole system makes sense. Lab for context, Anki for timed recall. But now, the third piece, the AI amplifier. We know we need these super focused Anki cards, but creating them sounds incredibly tedious. Going through man pages, pulling out every single option, making sure the answer is just the syntax.
Oh, it is tedious. Manually creating hundreds of high-quality succinct cards is a massive time sink. It can actually become a barrier to sticking with the system.
Right, you'd spend more time making cards than studying them.
Potentially, yeah. And that's where the generative AI comes in, not to learn for you, but to handle the grunt work of creating those optimized cards very, very quickly.
So the strategy isn't, hey, AI, teach me Linux. It's more like, hey, AI, take this task description and give me only the bare bones command syntax needed.
That's exactly it. The source is stressed, making the flashcard answers extremely short. Succinct and straight to the point was the phrase used.
Why so strict about brevity?
Because any extra words, any explanation on the answer side of the card actually slows down your mental retrieval during recall practice. It adds noise. You want just the signal, the pure command.
So what was the magic prompt? How did it get the AI, like Google Gemini, to generate these hyper-efficient cards?
It was surprisingly simple, according to the source. The core instruction was essentially, give me a much more efficient flashcard back. You provide the task description as the prompt or front of the card.
And the AI's job is to generate the absolute minimal syntax as the back or answer.
Exactly. Stripping away all the explanatory fluff. Let's walk through those user ad examples they provided. They really nailed this concept.
Okay, yeah. User ad is classic exam fodder because of all the different options you have to combine. Let's go through them slowly like you'd see them on a card.
Perfect. Okay, task 1. You need to add a username Jado and add them to 2 supplementary groups, wheel and audio. What's the command?
Thinking supplementary groups, that's dish EG. So user ad, dish G wheel, audio Jado.
Bang on. See how the AI generated answer would be just that? User ad dash G wheel, audio Jado. No explanation, just the syntax.
Right. Focus purely on remembering that capital G means supplementary and the comma separation. Okay, task 2. add user Jado, but set their default login shell specifically to bin bash.
Default shell. Okay, that's the nested option. So the answer is user add -s bin bash Jado.
Correct. Again, laser focused on the SS. Seems simple, but like you said, mix 50 flags together under pressure.
Exactly. That isolation is key. All right, task 3. Add user Jado, but you need to assign them a specific user ID, a UID of 1050.
Specific UID, that's SU. So user add -u 1050 Jado.
Perfect. Now let's combine things. This is more realistic for the exam. Task 4. Add user Jado, set their primary group to users, add them to supplementary groups wheel and dev, and also set the shell to bin bash.
Okay, well, primary group is -g. Lowercase, supplementary is -g, shell is -s. Need to get the order right, or does the order matter for the options?
Generally for user add, the order of the options doesn't matter, but the username comes last. So the AI would generate the clean answer. User add -g users -g wheel dev -bin bash Jado.
User add -g users -hg wheel dev -s bin bash Jado. Got it. That's juggling 4 distinct pieces of information. The lab gives you the idea you need these things. Anki plus AI drills the exact syntax.
Precisely. One more complex one. Task 5. Add user Jado. Add a comment field John Doe. Set a custom home directory app John Doe, and also add them to the wheel supplementary group.
Yeah, comment is -e free, custom home is -g, supplementary group is -g. So user add -e j-g app John dash wheel Jado. Remember the quotes around the comment?
Excellent. User add -e John Doe -esd app John Doe -g wheel Jado. That's exactly what the AI prompt strategy delivers. Pure, testable syntax, stripped of all noise. Ideal for that rapid-fire recall.
You basically optimize the signal, you know what you need to retrieve, and the card gives you only that.
You got it. They're maximizing the efficiency of each recall attempt. The goal is confidence in the exam room, minimizing any second-guessing about flags or syntax.
Okay, so let's zoom back out. The big picture here is this modern, integrated strategy for tackling something like the RHCSA. It directly confronts that forgetting curve problem.
Right. It starts with the foundation, consistent, hands-on labs that builds your context, your understanding, your muscle memory, your operational base.
Then you layer Anki on top. That's your automated recall engine using spaced repetition science to fight the forgetting curve and lock in the knowledge long term.
It manages the whole review schedule, which is just too complex to do reliably by hand at this scale.
And finally, the accelerator. Using generative AI strategically. Not to replace learning, but to generate those ultra-succinct, syntax-focused flashcards that make the Anki drilling hyper-efficient.
Exactly. Faster card creation, better focus during review, leading to faster recall under pressure. It's lab practice, plus algorithm-driven review, plus AI-assisted content generation.
It really reframes technical learning, moving it from just passively reading or randomly practicing to a much more active, targeted, and, well, scientific process.
It is. It's about optimizing how you encode and retrieve information.
So here's a final thought for you, the listener, to chew on. We've talked about this in the context of RHCSA and G and Linux commands. But think about the core principle. Using technology-spaced repetition software like Anki, maybe AI, for content trimming, to optimize when and how you review complex information, to deliberately counteract the forgetting curve.
Yeah, it's definitely transferable.
If you can apply this workflow to master Linux commands, what else could you apply it to? Networking protocols, cloud service configurations, programming language syntax. Think about how much more efficiently you could master any large technical domain in the future, just by making your learning process smarter now.